Myself, Sheikh Afrin Sultana. Today my topic is ergodic process. From the lesson Random Processes, Temporal Characteristics. Here we see the first definition of ergodic process. A stochastic process is said to be ergodic if its time averages are equal to its ensemble averages. In simple words, a process is ergodic when the statistical properties obtained from a single sample function over time represent the entire process. This means that observing the process for a long time gives you the same information as observing many realizations at one time. Key points are time average equals to ensemble average. One sample function is enough to describe the entire process. Ergodicity implies stationary, but stationary alone does not imply ergodicity. If you want, I can also give the mathematical expression or an example. In ensemble average, that means average value of many possible signals at a one-time instant. Time averages means average value of one signal taken over a long period. Ergodic means when both averages are equal means one signal is enough to study the process. Here we see the difference between ensemble average and time averages. Take some features as examples. First one, how average is taken. In an ensemble average, across all possible sample functions at a fixed time. In time average, over time for one sample function. Variable kept constant in time average, time t is fixed. In time average, one realization sample function is fixed. Type of average. In an ensemble average, theoretical or statistical. In time average, practical experimental. Computed from in an ensemble average, probability distribution fx of x, and in time average, single time record x of t. Used for defining mean correlation using probability theory. In time average, measuring power mean correlation from one signal. For example of ensemble average, average noise value across 100 different trials at a time t equals to 1s. Time average. In time average, average noise of one signal from t equals to 0 to t equals to 10 seconds. Possible to compute. Difficult in real life, easier, cannot be measured from one signal. And here we see the relation between the time average and ensemble average. For a random process x of t, the time average of a sample function x of t is a random variable. The expected value of this time average, the ensemble average, E of A of x of t equals to E of x of t equals to x bar, or E of x bar equals to capital X bar. This means that the average overall all realization ensemble average equals to the mean value of the process. Second one here, relation between time and ensemble correlation functions. For autocorrelation function, E of A of x of t into x of t plus tau equals to E of x of t into x of t plus tau equals to Rxs of tau, or equivalently E of Rxs of tau bar equals to Rxs of tau. Similarly, for cross correlation, E of Rxy of tau equals to Rxy of tau. Here bar represent the time and these are represent the average. And here we see condition for inequality ergodicity. If all time averages are constant, that is x bar equals to constant, Rxs of tau bar equals to constant, then E of x bar equals to x bar equals to x bar, and E of Rxs of tau bar equals to Rxs of tau bar equals to Rxs of tau. E of Rxy of tau bar equals to Rxy of tau bar equals to Rxy of tau. And here we can see the ergodic theorem and ergodic processes. If ergodic theorem states that for any random process x of t, the time averages of the sample functions of x of t are equal to their corresponding ensemble statistical averages. That is, x bar equals to capital X bar and Rxs of tau equals to Rxs of tau. Here these are Rxs of tau represent the time averages, and here these Rxs of tau represent the statistical averages. We see the difference between these and these. Here we write double R and here we write a single R. Ergodic process. Ergodic process means a random process that satisfies the ergodic theorem is called an ergodic process. In simple words, for ergodic processes, time averages are equal to ensemble averages. An ergodic process means that a single sample function contains all the statistical information of the process, although the mathematical analysis of ergodicity is complex. In most practical applications, all stationary processes are assumed to be ergodic. Jointly ergodic processes. Small x bar equals to capital X bar, small y bar equals to capital Y bar, and Rx of tau equals to Rxy of tau, and Rxy of tau equals to Rxy of tau, and Ry of tau equals to Ryy of tau. Here the Rx's of tau represent the time averages in autocorrelation, and these Rxy of tau represent the ensemble average in cross correlation. These Rxy of tau represent the time average in cross correlation. These Rxy of tau equals to represent the ensemble averages in autocorrelation. These Ryy of tau represent the ensemble average, time average, and Ry of tau equals to ensemble average in autocorrelation of y. Here we see some brief explanation about ergodic theorem and ergodic processes. Here, ergodic theorem means time average is equals to ensemble average. Ergodic process means process that satisfies the ergodic theorem. Jointly ergodic theorem processes means two ergodic processes whose cross correlation and autocorrelation match their ensemble averages. Here we see one practical note. Most stationary random processes are considered ergodic. Mean ergodic process. A random process x of t is said to be mean ergodic or ergodic in the mean if the time average of any sample function x of t is equal to its statistical average x bar, which is constant, and the probability of all other sample functions being equal to it is 1. That is, E of x of t equals to x bar equals to A of x of t equal to x bar. These E represented as expectation of x of t equals to, it can be represented as x bar equals to A of x of t equals to x bar with probability 1 for all x of t. Here from the definition we see that mean of ergodicity means sample function x of t is equal to statistical average. Here x of t equals to A of x of t, that means x bar. This condition gives the mean of ergodic process. And we see autocorrelation ergodic process. A stationary random process x of t is said to be autocorrelation ergodic or ergodic in the autocorrelation if and only if the time autocorrelation function of any sample function x of t is equal to the statistical autocorrelation function of x of t. That means A of x of t into x of t plus tau equals to E of x of t into x of t plus tau. That is represented by Rx of tau and Rx of tau. Here A represent the time average and E represent the ensemble average. Here we know that autocorrelation equals to x of t into x of t plus tau. So A of x of t into x of t plus tau represent the autocorrelation in time average, and E into x of t into x of t plus tau represent the autocorrelation in ensemble average. It can be represented as Rx of tau and Rx of tau. These represents the time average of autocorrelation of x, and these represent the ensemble average of autocorrelation of in x. And we see cross correlation ergodic processes. Two stationary random processes x of t and y of t are said to be cross correlation ergodic or ergodic in cross correlation if and only if the time cross correlation function of sample functions x of t and y of t is equal to the statistical cross correlation function of x of t and y of t. We can represent it as A into A of x of t into y of t plus tau equals to E of x of t into y of t plus tau, or Rxy of tau equals to Rxy of tau. A represents the time averages and E represent the ensemble average. We know that cross correlation equals to x of t into y of t plus tau. A of x of t into y of t plus tau represent the time average of cross correlation, and E of x of t into y of t plus tau represent the cross correlation in ensemble average. These are represent time average, and these are represent the ensemble average. So the condition is satisfied, then cross correlation characteristic is determined as Rxy of tau equals to Rxy of tau. And thank you.